A silent drone glides over a forest of impossible shapes. Below, hundreds of pine trees are frozen in a silent, twisted dance, their trunks coiled into perfect spirals and sudden, sharp bends. This is the real and very strange phenomenon known as the dancing forests. For centuries, these bizarre groves have sprouted across northern Europe, sparking tales of witchcraft and fairy curses in the Middle Ages, and leaving modern scientists utterly perplexed. By the end of this journey, you will have a complete picture of this enduring medieval mystery, from its legendary origins to the most compelling modern investigations. We will unpack why an entire forest might grow in corkscrews and examine the eerie historical period when most of these trees began their strange deformation. What does it feel like to walk into a grove where nature itself seems broken? Before science could offer its theories, people needed an explanation for the impossible. In the dark, whispering woods of medieval Europe, the twisted groves were not a botanical puzzle. They were a warning. The most pervasive legend tells of a witch's curse. A powerful sorceress, wronged by the villagers or simply filled with malice, would cast a spell upon a patch of young pines. As she danced a wild, unnatural dance under a full moon, the trees would mirror her movements, freezing her malice into wood for all time. To enter such a place was to invite her lingering rage upon yourself, but an even more haunting tale speaks of invisible revelry. In regions like the Kaliningrad Oblast of Russia and parts of northern Poland, locals whispered that these were the ballrooms of the Fae. At midnight, elves and fairies would emerge to hold their otherworldly celebrations, and any human foolish enough to stumble upon them would be compelled to join the dance. This was not a joyous invitation but a sentence. The mortal, possessed by the fairy music, would dance without rest, without food or water, until their heart gave out and they collapsed among the twisted roots. These stories were not mere entertainment, they were vital, functional folklore. For a peasant gathering firewood or a traveler lost on a forest path, the sight of a corkscrewed pine was as clear a sign as a skull and crossbones. It marked a boundary: do not enter, do not collect kindling here, do not linger after dark. The forest's deformity was a visible label for the invisible danger the community believed resided there. In Germany, near the Curonian Spit, the tales often blended with fears of the restless dead, suggesting the trees grew in the footsteps of spectral armies. Each culture layered its own deepest fears onto the bizarre landscape, using story to map the unknown. This embedding into local superstition was so complete that for generations many of these groves were simply avoided, left to grow in eerie isolation, which only deepened their mystery and preserved them for the modern eye. The legends provided a perfect, terrifying answer, but they also raised a deeper question. What if the truth was not supernatural but was somehow even stranger? The legends were a map drawn in fear, but the physical reality of these groves is even more unsettling to behold. To understand the true mystery, you must first see it clearly. Imagine a young pine tree, just a sapling, beginning its life like any other. Then, for a period of just a few years, something happens. Its trunk does not grow straight up toward the sun. Instead, it begins to twist, bending horizontally before curving back upward in a perfect 360-degree corkscrew, as if sculpted by an invisible hand. Other trees form tight, 90-degree elbows at their base, creating a sharp J shape before continuing their growth skyward in a perfectly normal, straight line. The most startling fact is that this bizarre deformation is not a random fluke affecting one lonely tree. You are looking at an entire grove, sometimes hundreds of trees, all bent and twisted in the same unnatural fashion, all frozen in the same strange posture from the same brief period of their youth. This is the hallmark of the dancing forests. The most famous example is the Crooked Forest, or Krzywy Las, in western Poland. Here, around 400 pine trees exhibit that signature sharp 90-degree bend at their base, all leaning uniformly northward. Just a few hundred miles away, on the Curonian Spit in the Kaliningrad region of Russia, another grove presents a different pattern, with trees forming those graceful, hypnotic spirals. Similar sites are scattered across northern Europe, silent enclaves of botanical rebellion. These are not the gentle curves of trees leaning away from a prevailing wind. Wind creates a consistent, gradual slant. This is something else entirely, a deliberate-looking contortion locked into the wood itself. Walking among them feels less like being in a forest and more like wandering through the fossilized aftermath of a silent, geometric storm. The uniformity is the key. Whatever force acted upon these trees, it was not random. It was a widespread, localized event that targeted a specific generation of pines during a very narrow window of time. This fact narrows the search for an answer dramatically, pulling us away from fairy tales and into the realm of tangible, if bewildering, history. The uniformity of the groves points to a cause that was both powerful and precise. When modern scientists first encountered these silent dancers, their logical first suspect was the very blueprint of the trees themselves, a genetic mutation. This theory proposes that the seeds planted in these specific groves carried a unique, heritable flaw. The mechanism would target the apical meristem, the tiny bundle of cells at the very tip of the growing shoot that acts as the tree's command center for upward growth. Think of it as the tree's guidance system. A mutation here could scramble the instructions, causing the new cells to be laid down in a skewed, spiral pattern instead of a straight, vertical column. It would be as if the tree's internal compass began to spin, and the trunk grew in the direction of that spin, resulting in those hypnotic corkscrews or sudden bends before the tree somehow self-corrected. The strength of this idea is its neatness. It perfectly explains the consistency. Every tree from that batch of seeds would inherit the same faulty instructions, leading to the same bizarre growth pattern, like a family sharing a distinctive trait. It also explains why the deformity is locked in time. The mutation might have only affected the function of the meristem for a few crucial years of the tree's youth before the tree's biology overrode it or the gene simply stopped being expressed, allowing the trunk to resume normal, straight growth. This creates that uncanny visual of a perfectly twisted base supporting a perfectly ordinary pine top. For a researcher, a genetic answer is elegant. It turns an eerie mystery into a simple, if rare, error in nature's code, but the theory quickly grows tangled roots of its own. If this was a successful, heritable mutation, why did it not spread? The trees in the dancing forest, like the ones in Poland, do produce cones and seeds. If the twisting trait was dominant in their DNA, we would expect to see these corkscrews appearing in younger trees nearby, or even in plantations where seeds from these trees were used. We do not. The groves are isolated islands of deformity. Furthermore, such a severe growth defect would usually be a major disadvantage in a dense, competitive forest. Straight trees reach sunlight more efficiently. A tree wasting energy on elaborate spirals would typically be outcompeted and die out, its flawed genetics removed from the population. Yet here these groves stand, thriving for decades. This leads to a pivotal question. Could something in the environment have triggered a temporary change, not in the tree's permanent genes, but in how those genes were expressed during a vulnerable few years? This line of thinking shifts the investigation from the trees themselves to the world they grew in. The genetic theory leaves a puzzling gap, but history offers a far more tangible suspect. Our second theory points not to a witch or a faulty gene, but to the practical, calloused hands of medieval craftsmen. This idea proposes that the dancing forests are not a mystery of nature, but a forgotten relic of human industry. In an age before steel and plastic, wood was everything, and for specific, crucial tasks, straight timber was useless. Shipbuilders, for instance, desperately needed strong, naturally curved pieces known as knees and ribs to form the skeletal frame of a vessel. A perfect 90-degree bend or a smooth spiral grown right into the grain of a living tree was far stronger than any piece of wood that had been sawn and bent into shape. It was a material of immense value. The same principle applied to furniture makers needing curved chair backs or farmers needing robust handles for plows and axes. So the theory goes, someone deliberately created this resource. They would have planted a grove of young pines in neat rows, and then, when the saplings were just a few years old and still flexible, they would stake them down. By carefully tying the tender trunk to the ground or to a frame, they could guide its growth into the exact shape required, a process that could take several seasons. Once the tree matured and the desired curve was permanently set into its core, they would harvest it. This explains the uniformity, and the neat rose perfectly. It was not a forest but a farm, a plantation of living raw material. The evidence is compelling. The trees in Poland's crooked forest all bend at the same height and in the same direction, as if following a template. Their placement is orderly, not random. This feels intentional, but then this practical theory crashes into a historical wall. If these were such valuable, cultivated crops, why were they never harvested? Why would a medieval community invest years of meticulous labor into shaping hundreds of trees, only to walk away and leave them all standing? It makes no economic sense. There is no record of a plague or war so sudden and complete that it would cause every single person who knew about this valuable timber to vanish simultaneously, abandoning a ready-made fortune in curved wood. Furthermore, if this was a common practice, why are these groves so exceptionally rare? We would expect to find remnants of such plantations all across Europe, but we do not. The hand of man theory gives us a perfect method but a baffling motive. It suggests a project begun with clear purpose, then mysteriously, universally abandoned at the very moment it was ready to pay off. This abandonment is its own quiet mystery, one that pushes us to look for a cause so overwhelming it could stop human hands from finishing their work. Abandoned tools and twisted genes both fail to explain the full picture, leaving us with a third, more chaotic possibility. Perhaps the true sculptor of the dancing forests was not a human hand or a flawed seed, but the environment itself. This theory looks at the world the young trees grew in, searching for a force brutal enough to bend them, yet temporary enough to vanish without a trace. The prime suspect is mechanical stress. A pine sapling is incredibly flexible in its first few years, its trunk more like a green, woody stalk than solid timber. If something physically pushes it over and holds it down during a crucial growing season, the tree will not break. Instead, it will do what all life does: it will adapt. It will begin growing its new wood cells not straight up but at an angle, fighting to get its crown back toward the sunlight. This creates a phenomenon known as reaction wood. In a pine, this special wood forms on the underside of the bend, pushing with incredible force to right the tree. If the pressure holding the sapling down lasts for several years, layer after layer of this stressed wood is laid down, permanently locking the bend or spiral into the very grain of the tree. Then, when the pressure is finally released, the tree simply continues growing upward normally, leaving behind a fossilized record of its childhood struggle. So what could apply such uniform, widespread pressure? The first candidate is a heavy, wet snowpack. Imagine an unusually severe winter where deep, dense snow falls and persists late into the spring. It blankets a plantation of young pines, not just covering them, but weighing their supple trunks down to the ground, pinning them in a horizontal position for months. As the snow finally melts, the trees begin their slow push upward, but the damage is done. The growth pattern for that year is set in a curve. If this pattern of heavy snow repeats for 2 or 3 consecutive years, each growing season adds another segment to the spiral. The result, decades later, is an entire grove of trees with identical snow-sculpted bends. Another possibility is a persistent, unusual wind pattern. Not the constant breeze that leans a whole forest, but a localized, swirling vortex of wind, perhaps channeled by the unique topography of a hillside or a dune valley. This mini-tornado effect could consistently push the saplings in one twisting direction, training them into corkscrews as they grow. Then there are animals. In medieval Europe, forests were often used as common grazing land. A herd of cattle or deer wandering through a young plantation could trample and browse on the tender tops of the saplings. A sapling whose main bud is eaten will often send up a new leader from a side branch, causing an abrupt change in growth direction, a sharp elbow in the trunk. If the animals returned season after season, the pattern of damage and regrowth could become consistent across the grove. The environmental theory is powerful because it requires no mysterious mutations or forgotten craftsmen. It relies on known physics and biology. A force acts, the tree reacts, and the memory of that event is sealed in wood. But even this elegant explanation stumbles on the same question of scale. For this to work, the environmental event had to be perfectly timed, hitting all the trees in the grove at the same young age. It had to be consistent, applying the same directional pressure for multiple years. And then it had to stop completely, never recurring with the same effect on the next generation of trees. We are left with a haunting image, a brief, perfect storm of conditions, a climatic anomaly that left its signature on a generation of pines and then faded from memory, leaving only the trees themselves as cryptic monuments to a forgotten winter, a strange wind, or a passing herd. The silent testimony of the wood itself may hold the final clue. To solve a mystery, you need to know not just how, but when. For the dancing forests, the answer to that question arrived not from old books, but from the tree's own hidden records. Scientists turn to dendrochronology, the study of tree rings. Each concentric ring in a trunk is a diary entry marking 1 year of growth. By extracting a thin core sample from a twisted pine, researchers could count these rings back to the tree's very first year. They could also measure the rings width. A narrow ring indicates a tough year of drought or poor conditions, a wide ring a year of plenty. By matching these unique patterns of wide and narrow rings to master chronologies built from thousands of local trees, they could pinpoint the exact year each ring was formed. This method allowed them to look directly at the rings laid down during the period of the strange bending. The results were startling in their consistency. Across multiple studies, especially of the famous Crooked Forest in Poland, the data pointed to a single, narrow window of time. The deformation, the event that caused the spirals and sharp elbows, most likely occurred in the late 1920s or throughout the 1930s. This is a fact that reshapes the entire mystery. The 1930s. This is not the dim medieval past of witch hunts and fairy tales. This is the era of radio, of early automobiles, of documented history. Yet, it is also a period still close enough to living memory that the echoes of old folklore would have been potent, especially in rural, forested communities. The date acts like a fault line, cracking open both our previous theories. If the trees were bent by human hands for shipbuilding, as the cultivation theory suggests, why would this be happening on an industrial scale in the 1930s? Steel-hulled ships were already dominating the seas. The economic rationale for such a labor-intensive timber farm collapses under the weight of modernity. Conversely, if the twisting was the result of a purely natural event like a freak snowstorm or a bizarre wind pattern, why is there no record of such a remarkable, localized climatic anomaly in the 20th century? Weather data from that period, while not perfect, exists. A storm severe enough to sculpt an entire forest would have been notable. The date from the tree rings gives us a precise anchor, but it makes the waters around it more turbulent, forcing us to consider that the cause might be a tangled blend of the human and the natural, born from the specific pressures of a world poised on the brink of catastrophe. The 1930s date from the tree rings brings us to the doorstep of the most iconic example of them all. Just outside the town of Gryfino in western Poland lies the Krzywy Las, the Crooked Forest. This is not a scattered grove of spirals, but a meticulously ordered plantation of around 400 pine trees, each one performing the same impossible stunt. Every trunk grows straight out of the ground for about a foot, then takes a sudden, sharp 90-degree turn to run parallel to the earth for 3 to 9 feet before snapping back upright and growing perfectly normally toward the sky. It looks less like a forest and more like a collection of wooden hockey sticks or a battalion of trees frozen mid-bow. The uniformity is absolute. Every single one of these dramatic bends leans in the same direction toward the north. This precise geometric repetition screams of human intention, and the historical context adds layers of intrigue. The trees were planted in the early 1930s, a time when this region was part of Germany, not Poland. The land was likely managed by German foresters or a local landowner. This detail transforms the Crooked Forest from a mere botanical oddity into a potential artifact of a specific time and place, a living snapshot from a world about to be shattered by war. The local legends here reflect that turbulent history. Some older residents whisper that the trees were bent by German tanks rolling over the young saplings during military exercises, a tangible, physical memory of occupation pressed into the wood. Others, reaching further back, tell a more mystical tale of a powerful wind from the north, a curse laid upon the land that forced the trees to kneel. Yet the tank theory falters under scrutiny. The bends are too uniform, too gentle. A tank track would have crushed and splintered the flexible saplings, not trained them into smooth, living curves. The sheer number of identically bent trees also points away from random trampling and toward a sustained, controlled process. Scientific expeditions to the site have measured, cored, and mapped every conceivable variable. They confirm the trees are all the same age, all from the same planting. The bend occurred in their first 7 to 10 years of life. Soil samples show nothing unusual, no toxins or mineral imbalances that could cause such a deformity. The leading hypothesis from researchers circles back to that idea of deliberate human cultivation. The prevailing theory is that the German foresters who planted these pines did so with a specific industrial purpose. They allowed the trees to grow for a few years, then used a specialized tool or technique to notch the trunks and stake them down, guiding the horizontal growth to create naturally curved timber for furniture, ship ribs, or even for the frames of wooden sledges. The fact that all the bends face north could be explained by a desire to maximize sunlight on the recovering vertical portion of the trunk. But this theory, so logical on the surface, is haunted by the same unanswerable question that shadows all the dancing forests. Why was the crop never harvested? The outbreak of the Second World War in 1939 is the obvious, chilling answer. The foresters who shaped these trees may have been called to war, never to return. The knowledge of the plantation, its purpose and its value could have been lost in the chaos, death, and redrawn borders that followed. The Crooked Forest stands, therefore, as a monument to a project interrupted, a purpose forgotten. It is a ghost of pre-war industry, preserved not by magic but by historical catastrophe. Yet even this explanation feels incomplete, leaving a silent grove of 400 questions rooted in the Polish soil. The haunting uniformity of Poland's Crooked Forest is only one variation of this strange phenomenon. Scattered across the globe, other twisted groves whisper their own versions of the same riddle, each with a unique and unsettling signature. Just a few hundred miles north, on the slender Curonian spit that divides the Baltic Sea from a freshwater lagoon, lies Russia's own aptly named Dancing Forest. Here, the trees reject the orderly 90-degree bends of their Polish cousins. Instead, they erupt in a frenzy of chaotic motion. Pines corkscrew into perfect loops, spiral like barber poles, or writhe along the ground in serpentine coils before lunging skyward. The effect is less like a cultivated plantation and more like a snapshot of arboreal panic, as if each tree was caught in a different moment of a violent, twisting dance. The soil here is pure, shifting sand dune, a landscape in constant, slow motion. Some researchers point to this unstable ground as a potential culprit, suggesting the tree's roots could not find secure purchase, causing the saplings to wobble and spiral as they fought for stability in their youth. Yet, this does not fully explain the loops and knots, shapes that seem to defy simple instability. Reports of similar anomalies drift in from the forests of Sweden, where certain pine stands are said to grow in gentle, widespread arcs. Even more intriguing are accounts from North America. In a remote corner of the Gaspé Peninsula in Quebec, Canada, a small cluster of pine trees exhibits a pronounced spiral growth. Across the continent, in California's Inyo National Forest, a famous bristlecone pine known as the patriarch tree shows a dramatic, gnarled twist in its ancient trunk. While these may not be dense groves, they suggest the underlying mechanism, whatever it is, might not be confined to a single continent or a single species. The critical difference between these global sites lies in their pattern. The Polish forest is a regimented anomaly, its uniformity pointing strongly to human intervention or a single, overwhelming environmental event that affected every sapling identically. The Russian grove is a masterpiece of chaos, each tree a unique sculpture, hinting at a more complex, perhaps ongoing interaction with a volatile environment. The scattered North American examples suggest the phenomenon can occur in isolation, a rare but possible outcome of local conditions. This global scattering deepens the central mystery exponentially. It argues against a single, simple answer. If the cause was a unique genetic mutation in one batch of Polish pine seeds, how do we explain the shapes in Russia or Quebec? If it was a specific German forestry technique from the 1930s, what shaped the trees on the Curonian Spit, where human cultivation is far less documented? The existence of these other sites pulls us away from a neat, localized solution and toward a more unsettling possibility. Perhaps we are not looking at one mystery, but several. The twisted forest may not be a single condition with a single cause, but a rare and spectacular symptom, a final, identical shape arrived at by different paths. A tree in Poland might have been bent by human hands for a war that never came. A tree in Russia might have been twisted by sliding sands and relentless wind. A tree in Canada might carry a genetic quirk amplified by harsh mountain weather. They all share the same breathtaking result, a frozen gesture of defiance against growing straight. This means the search for a universal answer might be futile. Instead, each grove may be its own locked-room mystery, its key hidden in the specific soil, history, and climate of its birthplace. The true enigma, then, becomes why nature, or humankind, so rarely leaves behind such dramatic and beautiful mistakes. For a woodcutter in the 1400s, the forest was not a scenic backdrop. It was a living, breathing entity, a place of both sustenance and profound danger. His world was one of signs, a flight of birds, the shape of clouds, the way a river flowed. All could be messages from God or omens from darker forces. Nature was the primary text, and every anomaly was a sentence to be read, often with fear. So imagine this man, his axe over his shoulder, stepping from the familiar, straight-trunked woodland into a silent clearing where the pines writhe in perfect spirals. His breath would catch. This was not a place of harvest, this was a place of violation. His first instinctive thought would not be of botany, it would be of boundaries. The unnatural uniformity, the trees all bent in the same unnatural way, would scream of deliberate action. But what hand could twist an entire grove? Not a human one. To his eyes, this was the work of invisible power. The orderly curves might resemble the trampled perimeter of a vast circular dance. This was a fairy ring on a monstrous scale, a ballroom for creatures far larger and more terrible than the sprites of local tales. he would see the marks of their revelry pressed permanently into the wood, a permanent scar of their presence. Alternatively, the sharp, angular bends could look like trees frozen in a permanent act of bowing or cowering. This was not a dance but a submission. It was a demonic circle, a place where the earth itself had been claimed and corrupted, forcing the very trees to kneel to a malevolent will. His interpretation would be a direct reflection of his deepest fears. If his village had recently suffered blight or sickness, the twisted grove would be a clear sign of God's wrath, a cursed place marking divine displeasure with the land. If tales of witches were common, he would see the proof of their Sabbaths, imagining a coven using the saplings as living candles in some unspeakable ritual, their magic warping growth itself. The folklore would not arise as a whimsical story around a campfire later. It would erupt fully formed in his mind at the moment of discovery, a terrifying, immediate explanation for the impossible thing before him. He would likely make a sign of the cross or clutch a protective charm. He would not gather a single fallen branch from that ground, for the corruption might be in the very wood. He would retreat, and his account at the village would not be a curious report of strange trees. It would be a warning. A new landmark of fear would be etched onto the community's mental map, its location passed down in whispers. The grove's real mystery, the cause of the bending, would be irrelevant. Its meaning, however, would be absolute. It was a place where the natural order was broken, and that could only mean one thing: something unholy lived there. This visceral, supernatural framing is the true origin of the legends we explored earlier. They were not invented for entertainment, but as vital survival logic, born from a single, heart-stopping moment of encounter in the deep, watchful woods. Long before the cross cast its shadow over Europe, the forest was not a place of fear, but of profound reverence. To understand the medieval terror of the dancing forests, we must journey back to a time when every oak, every spring, and every grove was alive with divinity. For the ancient Slavic, Germanic, and Baltic peoples, the woods were not merely resources. They were the sacred domain of powerful, capricious spirits. The most formidable of these was the Leshy, a forest lord who could grow as tall as the tallest pine or shrink to the height of a blade of grass. He was the guardian of all woodland creatures, and his mood dictated the fate of any human who entered his realm. A respectful traveler might be led safely to a path. A disrespectful one could be led in endless circles, lost forever in a green maze. Sacred groves, untouched by axe or plow, were the temples of these beliefs. These were places of worship, sacrifice, and communion with the natural world, where the boundary between the human and the spirit realms was believed to be thin and permeable. Now consider the location of many dancing forests. They are often found in isolated, ancient woodlands of northern Europe, regions steeped in these old pagan traditions. It is a compelling theory that these twisted groves did not first become sacred in the Christian era because they were strange. Instead, they may have been considered sacred long before, precisely because they were strange. A grove of trees growing in impossible spirals would have been the ultimate sacred site. This was not the work of a minor spirit. This was a direct, undeniable signature of the otherworld, a place where the Leshy or the gods themselves had physically reshaped reality to mark their territory. The uniformity of the twisting could be seen as a deliberate geometric symbol, a permanent rune written in living wood by an invisible hand. It was a place of immense power to be approached with offerings, not fear. Then came Christianity. As the new faith spread, it faced a formidable task: how to convert landscapes already filled with holy places. The strategy was often one of overlay, not erasure. A sacred pagan spring might become the site of a saint's well. A revered oak might be claimed to have the Virgin Mary appear in its branches, but some sites resisted this peaceful conversion. Places of overt, powerful strangeness, like the dancing forests, were harder to baptize. Their undeniable otherness was too potent, too alien to the new order. So the church often demonized them. The forest lord Leshy was recast as a devil or a demon. The sacred grove, once a place of communion, was redefined as a witch's Sabbath ground or a fairy haunt, a place of danger and corruption. The very same visual that once inspired awe now inspired dread. The permanent manifestation of otherworldly power was not evidence of divinity, but of a malignant, lingering paganism that needed to be feared and avoided. This spiritual rebranding explains the deep, visceral fear that clung to these groves in the medieval mind. The peasant crossing himself at the edge of the twisted trees was not just afraid of fairies. He was standing at a spiritual battleground where the old gods had been defeated, but their palpable, twisted monuments remained, a haunting reminder of a power that the new faith could not fully erase. The stories of witches and cursed dancers were not pure inventions. They were the new mythology growing like ivy over the ancient pagan stones of belief, obscuring an older truth about the forest's sacred and terrifying heart. Perhaps the trees were not sculpted by weather or men, but sickened. This leads us to a less explored but deeply intriguing corner of the scientific debate, the possibility of a biological intruder. Could a rare pathogen, a microscopic invader, have been the true puppeteer behind the dancing trees? We know that certain fungi, bacteria, and viruses specialize in hijacking a plant's growth mechanisms, causing spectacular and bizarre deformities. Crown gall disease, for instance, is caused by a soil bacterium that tricks plant cells into multiplying uncontrollably, forming rough, tumor-like swellings on roots and stems. Witch's broom is another dramatic example where a fungus or mite infestation causes a dense, tangled mass of twigs to erupt from a single point on a branch, resembling a grotesque nest. These are clear proofs of concept that microscopic life can radically reshape a plant's architecture. So, could a unique, perhaps now extinct, pathogen have infected the saplings in these specific groves? The hypothetical mechanism is fascinating. Instead of causing tumors or bushy growths, this specialized pathogen would need to target the tree's hormonal signaling in a very precise way. It might disrupt the flow of auxins, the plant hormones that govern upward growth and directional response to light. A sustained, low-level infection in the cambium, the thin layer of living cells just under the bark where new wood is made, could theoretically scramble those signals. The tree would still grow, but it would lose its sense of vertical direction, resulting in the uncontrolled spiraling or bending we see. This theory elegantly addresses the issue of timing and uniformity. A pathogen spreading through the root systems in the shared soil of a plantation, or carried by a specific insect that favored young pines, could infect an entire generation of trees at the same vulnerable stage. The infection might have run its course after a few years, either defeated by the maturing tree's defenses or simply dying out in the environment, leaving behind only the wooden scars of its brief, strange reign. It also offers a potential explanation for why the phenomenon is so localized and has not recurred. The pathogen may have been an ecological flash in the pan. Yet the pathogen theory stumbles on a major biological hurdle. Most diseases that cause such drastic structural deformities are not subtle. They typically weaken the host, stunt its growth, and leave other visible signs like cankers, oozing sap, or discolored foliage. The trees in the dancing forests, however, are otherwise healthy and robust. They grew to full maturity after their twisted youth, showing no other apparent signs of systemic illness. For a pathogen to affect only the trunk's shape without compromising the tree's overall vitality or leaving any other forensic evidence in the wood or needles would require a biological agent of astonishing specificity. It would be a disease that acted more like a precise, temporary genetic switch than a typical blight. While not impossible, it pushes the boundaries of known plant pathology, adding yet another layer of beautiful complexity to a mystery that refuses to be solved by any single, simple answer. A tree knows which way is up. This is not a choice or a learned behavior, but a deep, biological imperative called gravitropism. specialized cells in the roots and shoots contain tiny, dense starch grains called statoliths. Think of them as microscopic ball bearings. Gravity pulls these statoliths to the bottom of their cellular chamber, and this simple physical action tells the plant where down is. The roots, reading this signal, grow toward the gravitational pull, anchoring the plant. The stem, however, does the opposite. It receives the signal and grows directly away from it, pushing relentlessly upward toward the light. It is a flawless, ancient guidance system. But what if, for a few critical years, that system went completely haywire in an entire grove of young pines? This is where our mystery takes a turn into the realm of botanical malfunction. Imagine a ship's compass that begins to spin freely, its needle no longer pointing north but swinging in slow, unpredictable circles. The helmsman, trusting his instrument, would steer the ship in endless loops. Now picture that compass inside a sapling. If something disrupted the statoliths or scrambled the hormonal message they sent, the tree's command to grow up would vanish. Without that clear directive, the tender shoot would have no innate sense of direction. Its growth would become chaotic, dictated only by where the sunlight happened to be strongest at any given moment. Since the sun moves across the sky, the growing tip might chase it, leading to a gentle, sun-fueled spiral. Or, if the disruption was more severe, the growth could become truly random, resulting in those tight corkscrews and sudden elbows. This theory proposes a perfect storm of environmental conditions that could cause such a temporary breakdown. The specific soil in these groves, perhaps a unique blend of minerals or an unusual acidity level, might have interacted with the tree's chemistry. Combine that with a period of extreme moisture, waterlogged roots struggling to function, and a particular pattern of dappled, shifting light filtering through a dense canopy, and you have a recipe for sensory overload in a developing plant. The sapling's internal systems, bombarded with conflicting data, might have simply short-circuited. The gravitropic signal, usually a loud, clear shout, became a faint, staticky whisper. So the tree grew in confusion, tracing its uncertainty in wood. Then, as the tree matured and its systems strengthened, or as the environmental conditions normalized, the signal cleared. The statolith settled, the command to grow up was received loud and clear once more, and the trunk snapped back to its vertical mission. This would leave us with the exact phenomenon we see, a period of wild, directionless growth frozen at the base, capped by decades of perfectly normal, straight timber. It is a story of a lost generation of trees, ones that spent their youth wandering before finally finding their way. That 1930s date is not just a number on a tree ring. It is a shadow falling across a map of Europe, a continent holding its breath. The very same years the young pines in Poland began their strange contortions were the years the Nazi Party rose to absolute power in Germany. Militarization began in earnest, and the world slid inexorably toward a cataclysm. This chilling coincidence forces a darker, more pragmatic question. What if the Crooked Forest was not an abandoned furniture project, but a forgotten military experiment? In an era of frantic innovation for the coming war, could this peculiarly shaped wood have held a hidden, strategic purpose? Imagine the value of a naturally curved timber beam. In an age before advanced composites, such a piece was a structural marvel. Its grain followed the curve, giving it immense strength without the weak points created by sawing and bending straight wood. The German war machine had voracious and specific appetites. Their legendary panzer divisions required not just tanks, but thousands of support vehicles, supply sledges, and artillery caissons, all needing durable, shock-absorbent frames. The consistent 90-degree bend in the Polish pines is eerily reminiscent of the knee joints used in traditional wagon and sledge construction, but on an industrial scale. Perhaps more compelling is the world of aviation. The 1930s saw a revolution in aircraft design, a shift from fabric-covered biplanes to sleek, all-metal monoplanes. But that transition was not instantaneous. Early models like the iconic Junkers Ju-52 transport plane, still used a framework of metal tubes and, in some sections, laminated wood. A naturally curved wooden rib, harvested to a precise specification, could be stronger and lighter than a manufactured alternative for certain airframe components. An entire plantation of such pre-formed parts would represent a strategic resource, a living warehouse of raw materials shaped years in advance of need. Then there is the realm of camouflage and concealment. Could a grove of trees, deliberately trained into uniform, unnatural shapes, serve a purpose beyond the timber itself? A formation of oddly bent trees could be used to break up the silhouette of a hidden installation from aerial reconnaissance, an early form of visual disruption. Or the grove itself might have been a calibration site. If you were developing aerial photography for intelligence purposes, a geometric pattern of unnatural trees would create a perfect, permanent ground marker against which to test the resolution and distortion of your cameras. The most haunting possibility is that the project was simply too experimental, its ultimate application never finalized. A team of engineers or foresters might have been tasked with exploring the potential of grown-to-shape timber for various military applications. They would have planted, bent, and nurtured these test specimens, documenting the results. Then the war exploded. The researchers were conscripted, the records were lost in bombings or deliberately destroyed to prevent capture, and the silent, twisted grove was simply forgotten in the overwhelming chaos of conflict. This would explain the total absence of documentation and the complete abandonment of what would have been, in peacetime, a valuable asset. A secret with no one left to remember it becomes indistinguishable from a natural mystery. The forest then stands not as a monument to folklore, but as a ghost of pre-war experimentation, its true purpose erased by the very war it might have been meant to serve. The silence of the dancing trees is now being broken by the hum of modern machines. To move beyond theories, scientists have turned the full arsenal of 21st century technology onto these groves, searching for physical evidence hidden beneath centuries of soil and legend. One of the most promising tools is ground-penetrating radar. This device sends pulses of energy into the earth and reads the echoes that bounce back, creating a sonogram of the subsurface. Researchers have meticulously scanned the soil around the twisted bases of the pines in Poland and Russia, looking for the ghostly impressions of long-rotted wooden stakes, fragments of metal wire, or any other man-made object that could prove the cultivation theory. The soil tells its own story through chemical analysis. Core samples are examined for unusual concentrations of heavy metals, toxins, or nutrient imbalances that could have stressed the saplings. Scientists test for the faint molecular signatures of ancient pathogens or the lingering effects of a one-time chemical spill. Three-dimensional laser scanning creates hyper-precise digital models of every twisted trunk, mapping the exact geometry of the bends to look for patterns invisible to the human eye. The goal is to find a fingerprint, a single piece of data that does not fit the natural order. So far, the results have been as enigmatic as the trees themselves. In many investigations, the ground-penetrating radar has revealed nothing but undisturbed natural soil layers. No neat rows of post holes, no rusted nails, no traces of wire. This absence is a finding in itself, weakening the case for widespread human staking. Soil chemistry reports often come back normal, showing no dramatic poisons or deficits. The high-tech scans, while breathtakingly detailed, mostly confirm what we already see. The twists are astonishingly uniform, but they offer no new clue as to why. This lack of a smoking gun is profoundly frustrating, but it is also a vital part of the scientific process. It systematically eliminates possibilities, narrowing the field. Each empty radar scan makes a widespread, organized human intervention slightly less likely. Each normal soil test reduces the probability of a simple environmental toxin. The mystery is being refined, not solved. However, there have been intriguing, if minor, clues. In some areas, analysis has shown slightly compacted soil layers consistent with a heavy, persistent snowpack from decades past. Other studies note faint, anomalous magnetic readings in localized spots, though these could be caused by natural mineral deposits or even a single, buried piece of forgotten farm equipment. The most compelling modern takeaway is not a discovery but a consensus. Whatever happened, it was a temporary, surface-level event. It affected the young, pliable trunks but left no lasting chemical scar on the land and required no permanent physical infrastructure. The Earth, it seems, has swallowed the evidence. This pushes the weight of the explanation back toward transient natural forces or a human intervention so subtle and temporary that it has vanished without a trace. The dance of the trees remains, but the floor on which they danced has given up no secrets, leaving modern investigators to ponder an empty ballroom, listening to the echoes of a song that stopped playing nearly a century ago. The silence of these groves speaks loudly to the artistic mind. When reality offers a scene so perfectly strange, so laden with unspoken narrative, it inevitably bleeds into our stories. The dancing forests have done exactly that, escaping the confines of scientific journals to take root in our collective imagination, much as they once fueled the folklore of medieval villages. You can see their twisted silhouettes echoed in the dark, enchanted woods of classic fairy tale illustrations, where gnarled trees often form archways and tunnels that feel both inviting and threatening. This visual shorthand for a magical or cursed place likely draws from a deep, subconscious memory of real, impossible groves witnessed or described by travelers. In modern fantasy literature, they are a gift to world builders. Authors crafting realms where nature is alive with sentient magic often describe whispering woods or corkscrew groves as places where the rules of physics are bent, where travelers lose their way not just physically but mentally. These fictional forests become characters in their own right, silent observers with a palpable, eerie agency, directly mirroring the unsettling presence of their real-world counterparts. The influence extends vividly into visual media. In video games, especially within the fantasy and horror genres, environment artists use the aesthetic of the dancing forests to create instant unease. Walking through a digitally rendered grove of spiraled pines in a game like The Witcher or Skyrim triggers that same primal recognition of a boundary crossed, signaling to the player that they are in a space governed by different, often dangerous rules. Paranormal documentaries and mystery series frequently feature these locations as centerpiece segments, using drone footage of the contorted trees as a powerful visual hook. The narration often leans into the legends, presenting the groves as physical evidence for earth energies, vortexes, or forgotten pagan sites, modernizing the medieval fear into a language of supernatural investigation. Even blockbuster films use similar imagery to denote realms of ancient power or corruption, where the very landscape is twisted by dark magic or otherworldly influence. This cultural journey completes a profound circle. Centuries ago, people encountered the inexplicable and wove stories to explain it, embedding the groves into their local mythos. Today, we encounter the same inexplicable beauty and weave it into our global culture of fantasy and mystery. The trees themselves have not changed, but our way of framing their mystery has evolved from survivalist warning to creative inspiration. They are no longer just a warning sign on a peasant's mental map, but a shared symbol in humanity's vast library of the strange and wonderful. This transformation from local superstition to global icon is perhaps the truest testament to their power. They remind us that some mysteries are too compelling to be solved, too visually potent to be forgotten, and too deeply woven into the landscape to ever be fully separated from the stories we tell about ourselves and the unseen world. The path into a dancing forest is a journey out of time. You leave the familiar rustle of a normal woodland behind and step into a gallery of silent, frozen motion. The air grows still, the light seems to filter differently through the contorted canopy, and a profound hush descends. This is no longer just a cluster of trees, it is an experience, and in our modern age it has become a destination. Sites like Poland's Crooked Forest and Russia's Dancing Forest on the Curonian Spit are now marked on tourist maps, drawing thousands of visitors each year who come to witness the impossibility for themselves. They walk the neat rows in Poland, reaching out to touch the smooth 90-degree elbows, their cameras trying and often failing to capture the sheer uniformity of it all. On the Spit, visitors weave between the chaotic spirals, some so tight you could thread a rope through the center, each tree a unique sculpture in this open-air museum of the bizarre. This attention has forced a vital conversation about preservation. The very soil that holds these mysteries is fragile. In Poland, protective boardwalks now guide feet along designated paths, preventing erosion around the shallow root systems of the ancient pines. Fences keep visitors from climbing into the bends, as the weight of a person could stress the old wood. Signs in multiple languages explain the theories but plead for respect, for this is a living monument, not a playground. Most visitors understand this, speaking in hushed tones, their laughter muted by the atmosphere. They feel the weight of the place, the same intuitive awe that struck the medieval woodcutter, even if their fear has been replaced by curiosity. They leave offerings of coins at the base of certain trees, a modern echo of an old pagan impulse to acknowledge a site of power, yet not all interactions are so reverent. The quest for the perfect social media photo has led some to ignore barriers, carving initials into the bark or attempting to force their bodies into the curves for a viral snapshot. Each piece of litter, each stray footprint in the protected soil, is a small defacement of a rarity that has survived centuries. Rangers and local guides share quiet frustrations about this, knowing that the forest's survival depends on a delicate balance between sharing its wonder and shielding it from love that wears the form of consumption. Despite the crowds, the eerie magic persists. Visit on a misty morning before the tour buses arrive, and the silence is absolute. You stand alone in a grove where every tree tells the same strange story, and the modern world falls away. In that silence, all the theories, the genetic flukes, the snowstorms, the forgotten experiments feel like distant whispers. What remains is the raw, uncanny presence of the place itself. It still asks its unanswerable question, not through words but through shape. This enduring power to captivate, to humble, and to inspire wild speculation is the forest's final and perhaps greatest mystery. It proves that some wonders do not need a solution to hold us in their thrall. They simply need to exist, twisted and silent, waiting for us to walk among them and feel the chill of the unknown on the back of our necks. Yet for every haunting legend, a skeptical mind finds a foothold in the tangible world. The truth of the dancing forests may be far less magical and far more mechanical than our stories suggest. Let us play devil's advocate for a moment and lay out the most plausible, earthbound explanations. The principle of Occam's razor suggests that among competing hypotheses, the one with the fewest assumptions is usually correct. When we apply this razor to the twisted groves, the supernatural simply requires too many leaps of faith. The natural world, however, provides a catalogue of straightforward causes. Start with the most direct human intervention. We have the historical coincidence of the 1930s and the location within pre-war Germany. The theory of young trees being damaged by military vehicles, specifically tanks during training exercises, is often cited by locals. While a single tank track might crush a sapling, consider a regiment of heavy vehicles repeatedly maneuvering through a young plantation over several seasons. The flexible, green trunks could be pressed down, not broken, their growth tips damaged but not destroyed. This would cause the trees to respond by sending up new leaders at sharp angles, creating those uniform 90-degree bends as they struggle to regain vertical growth. Combine this with the known forestry technique of coppicing or bending trees for timber, and you have a potent mix of accidental damage and deliberate, if rushed, human shaping. On the natural side, the environmental theories hold considerable weight. A heavy, late-lying snowpack is a documented phenomenon in these regions. If a series of severe winters pinned the saplings down during their crucial early growth years, the resulting reaction would permanently lock in those curves. Similarly, persistent, localized wind patterns funneled by unique geography could train an entire generation of trees into spirals as surely as a topiary artist. Even animal activity, like a herd of deer repeatedly browsing on the tender leading shoots, could cause a whole grove to develop identical corrective bends. The true answer likely lies in a combination of these factors. A plantation of young pines, perhaps already intentionally shaped for a forestry experiment, is then subjected to an unexpected environmental stress, a historic snowfall, or an invasion of grazing animals. Or conversely, trees naturally bent by a freak winter are later discovered by humans who then attempt to manage and uniform the grove for future use, a project abandoned when war erupted. This blended scenario requires no witches, no fairy circles, no mysterious pathogens or gravitational anomalies. It only requires a coincidence of mundane events, each one perfectly ordinary on its own, converging at the right time and place to create something that looks extraordinary centuries later. The human mind craves patterns and narratives, especially when faced with the visually stunning. It is far more compelling to envision a moonlit fairy dance than to picture a slow, silent accumulation of wet snow. Yet the simplest explanation is often the quietest one, written not in magic but in the relentless physical logic of growth and pressure. This skeptical grounding does not rob the forests of their wonder. It merely shifts its source from the supernatural to the astonishing complexity of our own natural world. But a skeptical explanation, no matter how logical, cannot erase every question mark. The simplest theories still leave behind stubborn, unexplained residuals, quiet gaps in the story where the mystery seeps back in. Take the uniformity. In Poland's crooked forest, the precision is almost mathematical. How does a random tank maneuver or a heavy snowpack produce hundreds of identical 90-degree bends, all at the same height, all leaning in the same direction? Natural chaos does not create such perfect order. An army of tanks would leave a mess of crushed and broken saplings, not a regiment of identically trained soldiers. A snowdrift heavy enough to bend trees would collapse unevenly, creating a variety of arcs and angles, not a single, sharp template. The uniformity points to a guiding intelligence, either human or environmental, of a consistency we simply cannot replicate or find in the historical record. Then there is the isolation. These groves are not scattered everywhere a heavy snow falls or a forester once worked. They are rare, specific islands. If this was a common result of certain winter conditions, we would see twisted pines in countless northern forests. We do not. If it was a widespread forestry technique from the 1930s, where are the other plantations? The knowledge would not have been held by a single person. It would have been part of a trade, documented in forestry manuals or passed down through apprenticeships. Yet that knowledge appears to have vanished without a single clear record or living practitioner. The tools are absent. Ground-penetrating radar finds no stakes, no wires, no evidence of the physical infrastructure such a large-scale shaping project would require. If the tools were simple wooden frames that rotted away, why is there no trace of post holes? The soil shows no sign of such disturbance. This absence is a presence in itself, a silence that contradicts the very human activity we suspect. Finally, the timing is almost too perfect. The trees bent in the late 1930s, a period of immense upheaval, allowing for the convenient explanation that the project was lost to war. But this creates its own paradox. If the purpose was so valuable strategic timber for a nation gearing for conflict, why would it be so utterly abandoned? Even in the chaos of war, valuable resources were catalogued, seized, or used. A ready-made supply of perfectly curved wood would have been a prize. Its total disappearance from all planning and memory feels less like an accident of history and more like a key piece of the puzzle we have yet to find. These residuals are what keep the mystery breathing. They are the spaces between the lines of every logical theory, where the cool light of reason dims and the older, more primal wonder flickers back to life. We are left with a choice. We can accept the most plausible, grounded explanation and live with its imperfections, or we can acknowledge that some corners of the world retain their secrets, not because they are supernatural, but because the confluence of events that created them was so unique, so fleeting, that it left only a shape behind and took all its reasons with it. The twisted pines are not alone in their defiance of explanation. Our planet is dotted with silent, stubborn riddles written in stone, sand, and ice, each one a testament to the fact that some mysteries are content to simply exist. Consider the sailing stones of Death Valley. In the vast, flat expanse of the racetrack playa, heavy rocks leave long, meandering trails behind them in the cracked mud, as if they went for a leisurely stroll in the night. For decades, no one saw them move. The phenomenon spawned theories of magnetic fields, pranksters, and even subtle Earth tilts, until patient scientists finally caught the culprit on camera. It was a perfect, rare recipe of winter rain forming a thin sheet of ice, then a sunny day where the ice broke into floating panels, pushed by gentle winds which slowly, invisibly, shoved the rocks across the slick mud. The answer was beautifully mundane, yet for a century the stones held their secret. Then there are the fairy circles of Namibia. Across the arid grasslands, millions of perfect, barren circles dot the landscape like polka dots, each one ringed by a lush border of tall grass. From above, it looks like the work of a vast geometric artist. Local myths speak of dragon's breath or spirits dancing beneath the earth. Scientists have dueled for years, some arguing it is the result of fierce competition for water among the grasses, others pointing to sand termites that meticulously clear the vegetation. The debate rages on, with each new study adding a layer of complexity but no final consensus. In Antarctica, blood falls presents a different kind of shock. From the tongue of the Taylor Glacier, a waterfall the color of rust stains the white ice, flowing like a wound. Early explorers thought it was red algae. The truth is stranger. The fall's source is a trapped, ancient subglacial lake cut off from the atmosphere for millions of years. The water is rich in iron, and when it finally seeps to the surface and meets the air, it rusts, creating this perpetual, bleeding flow from a lost world. These places share a profound kinship with the dancing forests. They are all natural formations that, at first glance, appear impossibly deliberate. They look designed. They trigger that same human instinct to see a hand, an intelligence, a story in the landscape, and for long periods they resisted our best attempts to explain them. Some, like the sailing stones, eventually yielded to observation and patience. Others, like the fairy circles, remain contested ground. The bleeding glacier gives us an answer that only opens deeper questions about alien ecosystems locked in ice. This is the true context for our twisted trees. They are not a singular fluke, but part of a global pattern of earthly anomalies, places where the standard rules seem to pause and a different, quieter logic takes over. Recognizing this does not diminish the mystery of the groves. It elevates it. It suggests our world is still capable of creating pockets of wonder that operate on timescales and processes just beyond the edge of our everyday understanding. We solve one and another waits, reminding us that the map of the known still has beautiful, blank spaces. The human mind is a relentless detective, wired to solve puzzles and see stories in the shadows. Our deep fascination with mysteries like the dancing forests is not just about the trees themselves. It is about the irresistible itch they create in our own psychology. At the heart of this lies a fundamental cognitive trait called apophenia. This is the innate human tendency to perceive meaningful connections or patterns within random or meaningless data. It is why we see faces in clouds, hear hidden messages when a record is played backward, or find constellations in a scatter of stars. Our brains are not passive receivers of information. They are active, hungry interpreters, constantly trying to impose order on chaos to make the world predictable and safe. This instinct is a survival tool for our ancestors, quickly connecting the rustle in the grass to a potential predator or reading the patterns of animal tracks was a matter of life and death. But this same powerful tool has a flip side. When we encounter something truly random and inexplicable, like a grove of perfectly spiraled pines, our pattern-seeking machinery goes into overdrive. It cannot accept noise, so it insists on finding a signal. It cannot accept coincidence, so it demands a cause. For the medieval peasant, the most readily available pattern in his mental library was the supernatural. The twisting trees did not look like an accident of weather. They looked like the deliberate, malevolent artwork of a witch or the physical imprint of a fairy dance. His apophenia connected the dots using the cultural and religious framework he understood, creating a story that felt truer than no story at all. Fast forward to our modern era, and we do the exact same thing. We just use a different cultural toolkit. When we see those same twisted groves today, our pattern-seeking brains, steeped in science fiction and conspiracy theories, might immediately jump to different conclusions. We speculate about alien landing sites, strange energy vortices bending space-time, or secret government experiments with terraforming technology. The underlying psychological process is identical. We are presented with an ambiguous pattern, and we rush to fill the void with the most compelling narrative we can access, whether that narrative is 300 years old or ripped from a modern thriller. This meta-understanding is key to our engagement. We are not just watching a mystery unfold about trees, we are participating in a fundamental human ritual. The forest presents the Rorschach ink blot, and we cannot help but project our deepest curiosities and fears onto it. The enduring power of the dancing forests lies in this perfect storm. They present a visual pattern so striking and uniform that it feels undeniably intentional, yet the true cause remains just out of reach, forever tickling that ancient, hungry part of our mind that demands to know why. We are not just observers of the mystery, we are, by our very nature, co-creators of it. Those old tales of witches and fairy circles were more than just campfire stories. They were a form of early science, a narrative framework for a world without microscopes or meteorological data. When a medieval community encountered the dancing forest, they faced a genuine physical anomaly. Their stories did not dismiss the strangeness, they engaged with it directly, using the best tools they had: observation, pattern recognition, and cause and effect reasoning. The legend of the witch who danced and twisted the trees is in its own way a hypothesis. It identifies an agent, the witch. It proposes a mechanism, her magical dance. And it predicts an outcome. Entering the grove invites her curse. It is a complete, internally logical model for explaining the inexplicable. This narrative science served a crucial purpose. It preserved the mystery. By embedding the grove in a story of danger and sacred power, the community effectively placed a fence around it. Do not cut these trees, do not build here. Do not forget this place. The folklore acted as a conservation order, protecting the physical evidence, the twisted trees themselves, for centuries, until a different kind of investigator could arrive with different tools. This reveals a profound continuity in the human spirit. The medieval peasant pointing at the corkscrew pines and whispering of fairy dances, and the modern scientist taking core samples and analyzing soil pH, are driven by the exact same impulse, a burning need to understand. They are simply speaking different languages to describe the same awe. The stories were not wrong because they invoked magic. They were the first draft of an answer, written in the vocabulary of the time. They mark the moment human curiosity collided with a natural wonder and refused to look away. Our journey from fairy tale to research paper is not a story of superstition being replaced by truth. It is the story of a single, enduring question being handed down through generations, each era refining the inquiry with the tools at its disposal. The forest may never give up its final secret, but in that long, unbroken chain of wonder, we find something just as valuable, the timeless shape of our own curiosity. A silent grove of twisted pines is a library with a single, cryptic book. Its value lies not in the timber, but in the story permanently etched into its grain, a story we are still learning how to read. Protecting these sites is no longer just about preserving a curious landmark. It is about safeguarding an active crime scene in a centuries-old natural mystery, one where the evidence is alive and still growing. The primary threat is no longer the axe of a superstitious woodcutter, but the slow, pervasive pressures of our modern world. Climate change looms as a silent rewrite of the very conditions that may have created the groves. Altered precipitation patterns, more frequent droughts, or unseasonal storms stress these ancient trees, potentially weakening them or changing the soil chemistry in ways we cannot yet measure. The unique microclimate that has cradled the mystery for decades could be shifting beneath their roots. Then there is the footprint of our curiosity. Unsustainable tourism, while born of admiration, poses a direct physical danger. Compacted soil from thousands of visitors suffocates the delicate, shallow root systems of pines like those in Poland's crooked forest. Carved initials, broken branches for souvenirs, and litter introduce foreign elements into a closed system we are trying to decode. The very act of loving a place to death is a real and present risk. In response, conservation initiatives have begun weaving a protective net. In Poland, elevated boardwalks now guide visitors along designated paths, preventing erosion and giving the roots room to breathe. Protective fencing keeps people from climbing into the fragile bends. Educational signage explains the theories while pleading for respect, framing the forest not as a playground, but as a living museum and a fragile scientific resource. On Russia's Curonian Spit, the dancing forest lies within a national park, granting it a level of oversight and legal protection from development or vandalism. The philosophy behind these efforts is a blend of preservation and patience. We are acknowledging that our current technology, from ground-penetrating radar to soil analysis, may not be advanced enough to find the final clue. The solution might require tools not yet invented, perhaps a way to chemically analyze individual tree rings for the molecular signature of a long-vanished pathogen, or satellite imagery sophisticated enough to reconstruct the precise wind patterns of a winter 90 years ago. By ensuring these groves survive, we are holding the puzzle pieces in trust for future generations of scientists, storytellers, and simply the wonderstruck. We are betting that the trees, which have kept their secret through wars and witch hunts, will one day whisper their truth to a listener who finally understands the language. So we stand at the edge of the grove, looking back across the whole tangled path we have walked. We began with whispers in the dark, with witches and fairy rings that gave terrifying shape to the unknown. We then followed the lantern of science, examining bent saplings and tree ring diaries, considering the hands of forgotten foresters and the weight of ancient snows. We placed these trees on the map of a world marching toward war, and we saw their twisted forms reflected in our own stories and fears. Each thread is strong, yet each one, pulled alone, begins to fray at the questions it cannot answer. The folklore explains the fear but not the physics. The science offers mechanisms but stumbles on the profound uniformity. The history provides a tantalizing date but leaves a void where records should be. Perhaps the mistake is searching for a single, elegant solution to a mystery that was never simple. The true story of the dancing forests may not be a choice between man and nature or between accident and design, but a story of their fleeting, perfect intersection. Imagine a practical, local endeavor in the late 1920s. A landowner or a forestry service inspired by old carpentry knowledge decides to experiment. They plant a stand of pines in neat rows, not for straight timber, but for the specialized curved wood still used in sledges or barrel staves. They begin the slow work of training the young trunks, staking them with simple wooden frames. Then something unpredictable happens. A series of exceptionally severe winters blankets the region. Heavy, wet snow collapses onto the already pinned saplings, holding them down with a force far greater than the human-made stakes ever intended. For several growing seasons, the trees are subjected to this double pressure, the guided intention of the foresters and the crushing, chaotic power of nature. The result is a deformity more dramatic and uniform than anyone had planned. Then history intervenes, the foresters are called away, the project's notes are lost, and the war reshapes the world. The grove is forgotten, decades pass, the wooden stakes rot away into the soil, the memory of the experiment fades from living knowledge. All that remains are the trees themselves, bearing the amplified signature of that brief convergence. When new generations encounter them, they see only the impossible shape, not the layered history. The human part of the story vanishes, leaving only the spectacular natural artifact, which the human mind, craving narrative, then cloaks in the oldest language it knows, myth. This synthesis feels deeply human. It is a tale of a plan interrupted, of nature collaborating with and then overwhelming human effort, and of time erasing the context to leave behind a riddle. It accepts that the most enduring mysteries are often palimpsests, where one truth was written over another, and only the final, cryptic text remains for us to decipher. The dancing forests, then, are not a problem to be solved, but a landscape to be read. They remind us that the past is not a single thread, but a woven tapestry where practicality, catastrophe, and wonder are forever intertwined. The twisted pines stand as a perfect enigma, a seamless fusion of medieval folklore and modern scientific debate. They are a living question mark rooted in soil and story. What continues to captivate us is the elegant collision of their uniform, almost manufactured curves with the chaotic sweep of history and nature. The precise 90-degree bends, the hypnotic spirals, the eerie fact that so many of these trees began their strange dance in the 1930s, a decade of looming shadows. These details refuse to fit neatly into any single box. The legends of witches and fairy revels were not primitive nonsense. They were the human mind's first brilliant attempt to map the impossible, to give a terrifyingly beautiful shape to something beyond understanding. Today, we replace those tales with hypotheses of snowpack and secret forestry, yet the groves retain their power to humble our certainty. In the end, perhaps that is their greatest gift. They remind us that our world remains capable of quiet, magnificent strangeness, of holding secrets that do not need to be solved to be appreciated. They invite us to stand in that hushed space between what we know and what we can only wonder about. What do you think shaped these forests? Share your own theories in the comments below. If you love unraveling historical mysteries like this one, be sure to subscribe for more deep dives into the world's forgotten puzzles. And if you ever get the chance, walk into a crooked forest yourself, feel the silence, touch the ancient, twisted wood, and for a moment stand inside the mystery.